I do know that. Okay, here's where you are. Brooklyn by yourself, Delaney and Heath, Bill and Elijah. Sorry, that was backwards. Sorry, change that. Drew, Maddie, Roth, Jenny, Danny, Isabel, Jenna. Front row, Aubrey and Riley, Emily by herself, Jules by herself. Now, Elijah, Jill, Keith, Delaney, Brooklyn by herself. Maddie by herself, that'd be Maddie, Marco, Grace, Laney, in the middle, Kate and Jaden, Kara by herself, Brianna, Luke. Okay, take out a blank piece of paper and write this down under proportions. Proportions and cross products. And please focus on this because if you don't, things are going to get a little crazy or What we do for today is based on this one small premise. If I have 5/8, somebody give me another fraction that equals 5/8. Anything out there. Jaden, shoot, I can tell you something about it. Another fraction that equals 5/8 that you don't use 5 and 8 for. 10/16. That's a good one there. Cross products is based on the notion that this happens, people. When I multiply my diagonals here, 8 times 10 is what? 80. And 16 times 5, if you do it out, is 80. When you have equal fractions, which are what proportions are, when you multiply the diagonals, they have to be equal. Just like if I had 1/2 and 8/16, 2 times 8 is 16 and 1 times 16 is 16. Equal fractions, when you have them, will give you equal cross products. That's what this is. When you multiply the diagonals, those are the cross products. Okay? Please make sure that you understand when two fractions are equal, you cannot and you do not ever cross cancel. Okay? This is 8 and this is 10. You can't reduce those. That's only when you multiply fractions. These are equal fractions. You only cross cancel when you have multiplication. This is equal fractions. There's an equal sign and you use cross products. Don't get cross canceling and cross products mixed up. They don't. They're not really the same thing, nor can they do. Now, what that means is this. The book will ask you a question like this. Is 6/9 are 6/9 and 7/11 proportional? And when they ask that, they just mean, do those fractions equal the same thing? And the way you respond to that is this. You do cross products. 9 times 7 is 63, and 11 times 6 is 66. If these two cross products are not the same, this is not proportional. Okay? Which really leads you to ask, so what? So what? Well, you ask, it's good to know, because you can do problems like this, right? If I have 7/8 equals what number over 24, you can probably tell me what the letter n equals, correct? Luke, what's the letter n equal?
21.
21, absolutely. Why did Luke know that? Because he said 8 times 3 is 24. So 7 times 3 is 21. Everybody's good with that. But, Luke, Mr. Smarty Pants, if you have this, and maybe you can figure this out, maybe you can't. If I have that, sir, or anybody out there in 6th grade land, what does x equal? What these are looking for. See a turtle. You might be able to figure this out. Maybe, maybe not. Some of you, given enough time, you are. Lainey Kovarik says?
15.
How'd you know 15, Lainey?
Because 10 times 9 is 90, and 6 times 15 is 90.
Oh, okay. I thought you were going to tell me something else. Lainey did it exactly what I thought she was going to mess my whole lesson up today. She did exactly what I'm going to tell you to do here. Because you know the cross products must be equal on this, because you can't just go 6 times what is 9, even though some of you might. Anybody know what 6 times what is 9? No, not 6 times 9. 6 times what is 9? Yeah, 1.5. That's fine. Okay, good. You don't know. If you can't do that like you did here, this was pretty easy because 8 times 3 was 24, so 7 times 3, but I can't do that here. 6 times, well, a big question mark is 9, so I don't know what to do with 10. If you can't do that, that's when you use cross products, which is what Lainey Kovarik just said there. That's when you do this. You get, okay, 6 times what number equals 10 times 9? And 10 times 9 is 90. And you might have to do a little bit of work here. 6 times what number is 90? Lainey must have done that in her head, but if you can't do it in your head, you're going to have to actually do it out on a piece of paper. And you get 15. X equals 15. Now, Lainey could do that, but what about this? What if I had 1 over 6 equals what number over, I don't know, 14? 1 over 6 equals what number over 14? Now this one here, I'm guessing you probably can't do in your head, even Lainey Kovarik doing those steps in your head, but you can always do a proportion with cross products, and it's always done the same way. You take this times this, 6 times what number equals 14 times 1. And we kind of write it out like this usually. 6n equals 14. Now does 6 go evenly into 14? It doesn't, but you can still do the problem, right? You take 14 divided by 6, and what's your answer going to be? 2 whole times, and make a fraction out of this. 2 and 2/6, which is 2 and 1/3. Unfortunately, 6th graders, as you get into older maths, not everything works out nicely in a nice, neat little thing. Let's see another one that might not work out. How about this one? Most of them are going to work out for you. How about 12 over 16 equals what number over 20? 12 over 16 equals y over 20. I'll give you a second. See if you can figure that out. 12 over 16 equals what number over 20? And you might actually have to do some calculating there. Believe it or not. And hopefully it should have looked like this. 16 times y equals 20 times 12. 20 times 12 is 240. Did somebody do 16 into 240? Randy, what'd you get? Oh, that doesn't seem right to me. You did 240 divided by 16? You get 16. I get 16 goes into 85 times. I get 15. So you're gonna make some sort of mistake there. How many people got 15? Now, Elijah Fisher is raising his hand. And he's raising his hand because of this. Elijah, when he did this problem, sometimes there's more than one way to skin a cat, took a look at this and said, you know, 12 over 16 is an unreduced fraction. Correct? 12 over 16 is the same as what fraction? What can you reduce it to, Brianna? Go all the way down. As low as it'll go. 3/4, because you divide them both by 4, you get 3/4. Well, if you reduce this to 3/4, then you actually do get a number that multiplied by something will give you 20, Elijah, which was 5. And if you multiply 3 times 5, you do get the same answer there. Which is fine, people. If you do that way, it is fine, but I will tell you that not always will you be able to reduce, and there are going to be times when you will have to do it this way. I'm okay with you doing it this way. It doesn't bother me in the least. It's kind of actually usually not a little bit more than whatever. But there are going to be ones where there's no way they'll reduce and there's no way they go into it, like that one that I did here, and you ended up with this fraction. No way of doing that other than doing those cross products ways. So you need to have that in your little arsenal of mathematical weapons, just in case that happens to you. But yes, feel free to look for it. If that fraction does reduce, you can reduce it and do it that same way, but always know that cross products will come up in your future. There's no escaping it, so don't try to completely avoid it at all costs. Perfect. For tomorrow then. I believe I have